So I wanted to thank Facebook for inviting me to present today. I really appreciate that. And I didn't really come up with a title because I'm not good at coming up with titles. So this morning we watched Starsky do this great presentation called Managing a Hybrid Network at Facebook. So I'd like to call this Managing a Hybrid Network if you're not at Facebook. So just a little bit about me. I like to think that I've been doing disaggregation since about 2000, the year 2000. I cut my teeth writing microcode for network processors, which is kind of, I've seen what Barefoot is doing now. It's kind of a renaissance of that. It's pretty cool. And I was very early on in the DevOps for networking. I built some libraries for Junos automation in Python. And we, as a team, we contributed a lot of open source code back to, Puppet and Chef and Ansible. So feel very passionately about how can we bring this really great technology or this new capability to the networking teams. Because like Starsky said this morning, many of these problems, even at Facebook, everybody has in networking. They want to have the same agility that the compute and server teams have and the application developers have. They want the same kind of business agility. Because at the end of the day, they want the network to be always on and always ready for their needs. But at the same time, you need the ability to reduce your operational risk, right? You want to make sure you limit your downtime. And a great way to do that is having technology that you can put in the hands of your network engineers so that a good network engineer can have, great engineering capabilities. And great engineers can have technology that lets them focus on really hard problems and deal with the minutiae of the small problems through, technology. But the real big challenge, as I was looking through, different ways of doing network automation while I was at Juniper, one of the real big challenges that we saw over and over again was this fractured, I don't want to say disaggregation, but the fracture between, building configs and then understanding the operational state of a network, right? There's configuration management tools. There's a lot of tools that do operational gathering, but there's nothing that really put it back together that rationalized your configuration and your operational state from essentially what the network engineer really wanted. So wouldn't it be great, as Starsky said, if we could go from this is what the network engineer wants, their intent of the network services, and simultaneously from that source of truth, get both the configuration and understand from that design what telemetry needs to be gathered and how that telemetry can be compared against what the network should be doing. So we kind of covered that, this morning. So I took out 90% of my slides. And so now we're down to 2 slides that I'm going to cover today, really talking about how we at Apstra built a system like Facebook, some of the differences and technical approaches. And then I'm going to spend the majority of time really just going through and showing you how it works. So all of this is going to be video demonstrations of the product in the varying aspects of how it works. So we're Apstra. Hi, Jeremy. We build software for network engineers, right? This is software built for the network engineering community that allows them to lifecycle manage network services in a vendor agnostic manner. And what we mean by that really is vendor inclusive. We want you, to have the ability to have choice and control over whatever hardware you'd like to use, whatever operating systems you want to use, whatever control plane protocols that you want to use. We don't want to limit that choice in any way, and we don't want to, say it has to be done a certain way. So we use the term vendor agnostic, really meaning in a vendor inclusive way. And the software that we build provides the network engineer with design automation tools, and from those design automation tools, for example, I want to build a spine leaf data center fabric to support, 1,000 servers at 10 gig, and I want my spines to be 32 ports of 40 gig, and et cetera. So there's design information, and from that design, the network engineer can create what we call a blueprint that allows them to put into that design all of the things that are necessary, like IP address pools or ASN values or whatever it is that design requires. So we'll call those parameters. And of course, you want to assign the devices themselves, so associating devices to a blueprint, and then put that network into production, like deploy that network. So how do we take the thing that was built, the configurations that were built, and all of the metadata artifacts that were built as part of the build process? So for example, a piece of metadata is the cabling map, right? The cabling map, how ports are connected to one another, is not a configuration element. It's a result of a design. That's a piece of metadata. And because we manage and understand that metadata, we then can, as we gather, say, LLDP telemetry, we know how to take that data, that raw data, and match it to the expectation of the design. So that step of build is not just configuration building. It's building the configs, of course, but it's also building all these metadata artifacts and then building all of the telemetry expectations that are specific to that reference architecture design. So we then provide the ability to automate the deployment of that process, make sure the systems comes up in a live and operational manner, and then we go into this continuous validation loop where our software, which generally runs directly on the device as a daemon or we call it agents, it's constantly spinning back the data back to our server, and then it's collecting that data and then providing this engine of anomaly detection. And I'll kind of go through that. But this is what we mean by design and operate in the stages of our product. How we do this, I'm going to kind of talk through this picture in a couple different ways. In the middle, or the platform technology, right? We're not a platform technology company. We're a software solutions company. But at the core of our technology is a distributed data store. And so, the yellow here really represents this OS platform or console technology. The distributed data store is what allows all of these stateless processes, and those are represented by the blue color here. That's software. Those pieces of software interact or communicate with a distributed data store such that the data is in a mechanism by which some people write in and some people wake up and notice that, hey, some data is in my data store and I need to do something with it. So when we talk about a pub-sub interaction between the software and our distributed data store, we're not talking about a message passing kind of architecture. We're talking about a distributed data store where think about these applications as mounting a database or mounting an NFS kind of file system, and as people write into files, other people wake up and react to that system. My background as a software engineer, I used to write embedded software for phone systems, like at Motorola and Nortel. I'm that old, and this is the same exact architecture that we had in phone system technology. There was a distributed data store where all the processes interacted through this mechanism. So, fundamentally, I've had the experience to know that this kind of architecture scales, it's reliable, and so I'm very excited that we're doing this. The way that we represent the colors in the blue, the orange in the middle, really is the data that the system manages. And in this architecture, or in this data model, if you will, we have this concept of a reference design, as I spoke of. The intent here is really what the network engineer wants the network to do. And from that reference design, we fabricate or model a collection of individual network services that need to be composed in order to implement that holistic service. And from that, we are able to generate the configs and all the other artifacts that I described. But here what we have is this, at the bottom, part of those services is to gather the status, look at that information relative to the intent of our service, and then generate anomalies. Like, is this right? Is this not right? So if somebody says, is my data center fabric cabled correctly? You know, like, is my physical layer correct? Or, is BGP operating properly, right? And we put that into context in terms of the network design. And I'll show you that. Now, one of the more interesting things that we looked at that I've seen in the marketplace about how you do this is where does the device agent live? Is it agent? Is it agentless? Is it on box or is it off box? Our architecture supports both, so we don't get into a religious debate with how that would work. There's some devices, these modern data center devices, allow us to put our software directly on the box, and in some of the more legacy systems, we would do this in a proxy model, but still take advantage of a distributed system that provides us the resiliency to restart services and so forth. So that's all the slides that I have about our architecture and some of the technology, and I'd like to go right into some of the demonstration. So what we have is our server technology. So our product is called AOS. It stands for the Apstra operating system. And our server technology then communicates to the agents that reside on the devices. So in this demonstration, we have our AOS talking to the snap route via the RESTful API, that sits on top of Open Network Linux on the wedge. Likewise, we've got our agent running in a Cisco NXOS guest shell. And then on a Cumulus running a Dell 6000, we have our software interacting with the Quagga processes in Cumulus Linux. And what I've got in the rack in the hallway, and what I'm going to demonstrate, is a design that's a 2-rack design with Cisco and Dell as the spines. And the wedge is acting as leaf switches configured in a 48 by 10 plus 6 by 40 mode. And we're going to do this using a modern data center design where we do routing on the host, which means we actually have Quagga running on the servers, and they're peer exchanging their routes with the leaf. And so AOS manages all of that networking across your entire design. So what that looks like when we build it is AOS will create the pictures for you and show you exactly where agents are running and the health of those agents. So I've got 13 minutes of video, and I've got 8 minutes left. This will be great. So for all the video that I don't cover, we will, we'll be out in the aisle. So let's start. Let's start with when you look at AOS and you say, I want to take a look at my operating a blueprint. What we have here is a blueprint that is comprised of 2 leafs, 2 servers, and 2 spines, 2 leafs, and 20 servers. Okay, so when we select this blueprint, we can immediately see what we can get that topology view, and we can see that all of our devices have been deployed and everything's operating correctly and the world's a happy place. From this viewpoint, we can kind of have different views of BGP, our cabling, routing anomalies, and how that would appear. We can select any given node, and from this we can kind of, on the right side, see specific node information that is a result of configuration. It's a result of gathering the facts or information about the devices themselves, like the serial number, the management IP address, and then all of the telemetry services that are active on this device, and whether or not they're okay or not. So this is clearly showing you everything's A-OK. This happens to be a Cisco. We can also see the configuration that was generated as a result of the blueprint and the design. And if we wanted to, we can see the exact same for a wedge switch that is running SnapRoute. SnapRoute has this really awesome data-driven API. So what we do is we model that as JSON. This feeds directly into a structured API, which is a very modern and slick approach. I like it coming from Juniper. We had netconf and XML. It's great to see a structured data set. We're doing all the port mode conversions as well as all the IP address configuration. Also part of this configuration is the fact that we're doing DHCP relay so that when the attached servers come up, they can get their IP address and then bootstrap through the network. And then finally, in the configuration, we're seeing all of the BGP, all the hard BGP, in order to make this specific design operational in the network. And so, Apstra provides you, the user with all the Jinja templates that fabricate these configs so that if somebody wanted to tweak or modify them, they can do that. And then finally, as a server that we're managing, we can also look at the configuration. This is an Ubuntu server running Quagga, and so you can see how we're managing and providing configuration to the servers. I want you to take note that there's some specific IP addresses here, like a 15 prefix and a 12 prefix that have been put into this configuration, and we're going to come back to that in just a sec. Okay, so now that we looked at the configurations, how did that come to be, right? When a network engineer builds a design, they need to provide these blueprint parameters that go into the design, and they can see different nodes and how the information is put in 2 different kind of formats. We saw the topology view. And then we can also see a table view where they can put more information in, and maybe this is really good for searching and sorting. So if we want to then see, well, how did all this data get into our system? This is the area of our product where the user would specify the particular blueprint attributes. So here you can see we're we have this model in our design called a Facebook disaggregate leaf switch. That's our 48 plus 6. And here, we've selected a snap route wedge to provide that function in this design. And then we have our spines as 32 by 40 gigs, and we've got one Dell and one Cisco. And then finally, we model a generic Ubuntu server. So this UI is completely RESTful, or I should say the UI sits on top of the RESTful API that our server provides. So everything that you see here can be fully automated through a REST API. And part of the customer enablement team is we write libraries to make that easy. We built some Ansible modules to automate some of this stuff, which is really cool. And then part of the data that fits into the blueprint is AOS's ability to manage resources. So if you don't need to artisanally handcraft your ASN assignments, you can just say, here's a pool AOS, you do the assignment for me. And we kind of give you the ways in which you can scope those assignments. So here we've got spines and leafs and servers, and they're all using the same private ASN pool. So as we go through this blueprint configuration, this is specific to this design architecture. If you had a different design architecture that had different sets of parameters, you would see different kinds of inputs here. So there's the DHCP IP server, and then we have the ability to control which routes are coming in and out of this fabric. So if you wanted to have fabric local subnets, for example, this 12 prefix, you can put your prefixes on the internal subnets, and then you can put your external prefixes on the external subnets. And then AOS handles the configuration in a vendor-agnostic way to make that happen. That's the intent of the network. OK, so I talked about an artifact called I'm going to make this aspect ratio slightly bigger so you can see it. So this is what the cable map looks like that AOS will fabricate for the network engineer. And it gives you, the from and to of every device and its port along with the IP address. And this information, can be sorted visually. So if we only wanted to look at say the spines and the leafs, here's the part where you can actually override the IP addresses if you wanted to do that. But if you wanted to kind of filter this down to just say spine leaf connections, you can filter this information down. So it's a very intuitive user interface. And then if we wanted to filter this information differently, for example, looking at the server to leaf connections, we can look at that information. And then we have the ability to download or export this data via CSV. So if you wanted to share this with your facilities people, they could just literally take a CSV file and have this as a spreadsheet. Because we have this now, I'm going to show you the telemetry part. So our services are running. We've got our agents collecting data, pushing that data back up. So now we want to do link validation, and I will show you under our telemetry screen. We have link validation, and what it will show you here is a visual representation of what your expectations are and what is up and what is connected. So here we can see that the green interfaces mean they're up, and the green lines connecting them means that they are actually connected to the proper place. If they were not connected to the proper place, you'll see the red, which I'm going to show you in a moment. But you get the idea of where you can see it. And you can change your point of view. So you say, well, maybe I'm standing in front of the spine, and I want to get the point of view from the spine. So yes, it's pointing to a server. Sometimes I don't know my own script. It's OK. But this is basically showing you can highlight over certain aspects to get some data. So you can go and kind of change your point of view. So here's a view from the spine and what it's connected to. So that's basically link validation, and we'll kind of see what it looks like when somebody makes a mistake and what that blast radius looks like. So before I go into showing you that very cool thing, I'm going to show you all of the other pieces of telemetry that we gather. And what's important is because we know the design and we know the elements of the design, we can contextualize the telemetry, meaning we are gathering information about interfaces and cabling in BGP, but we can also tell you this information relative to the IP fabric, so the spine leaf interconnects, or does it relate to the external router connection to the rest of your data center, or does it relate to, say, the connectivity between the leaf and the servers? So you can contextualize this information, and what that allows you to do is get really advanced mean time to insight, like where the problem is and who is being affected by what problem you're seeing. So this is just showing us a very happy green board. If there were errors and you were to click on any of these areas, it would show you exactly those errors. I'm going to show you that soon. We have another way to display the errors in kind of a heat map, so there's no anomalies there. But when we create some anomalies, we'll see that. Another way to look at the same kind of information in a device way is to select a device or just drill into the specific information you want to look at. So here, in this design, we have some number of BGP sessions. And this is giving you, again, contextual role-based information where those sessions are. We can see that some of them are spine leaf. One's going to external router. They're all up. And here, this is showing you your neighborship or your cable validation. We can see that it's cabled correctly. We can get information about who we're connected to, so you have that kind of insight and visibility. And then we also gather the routing table, so we know whether or not your routing table is correct. So, are the routes that I expect to be in my routing table actually present? And if they're not there, we see anomalies. And then finally, of course, you need to have interface information and that kind of status. We show you more information that isn't relevant to this blueprint as unintended. So, we show you all the information, but we only show you, we green and red only that's relevant to this design. Okay. So let's go into what does a broken link look like. So let's say you wake up one day and somebody's screaming and so something's wrong with the network. And you can see right now, I can see that these devices, these two spines in this leaf are affected by some problem. And I can drill into these services and I can see that the problem is isolated to my IP fabric. I've got some cabling and BGP issues. And now I've got some routing table issues as a result of that. So I can also see the heat map of the blast radius of this problem, right? I can see exactly which devices are effective and kind of the severity or how many issues in relation. And then I can even look at the routing table, and then I have all the IP addresses that are affected by this problem. So if you needed to match up an IP address to a server or an application, we can immediately say, is this IP address affected by this problem? And again, via RESTful API, you could query that information and see it. There are many ways of kind of filtering and viewing the information. So everybody has a different way they want to see the information. We've got tables, we've got visualizations. And then finally, this is what the link visualization looks like. We can clearly see that we've got a crisscross between this leaf and spine 1 and spine 2. So somebody accidentally got spine 1 and spine 2 mixed up. Okay, so if I wanted to, again, drill into a specific device to see how a specific device is affected, again, I could go and I can see this. This is the leaf. This is the gathering information from SnapRoute and communicating, to this case, between a Cisco and a Dell. So here we can see what's affected, what's not affected. It's a very clear visualization. And we can see, again, that it's spine to leaf. And our API provides a list of just all anomalies filtered down by a device so we can gather all of that data. Now, as we gather all this telemetry into the server, we will stream all of that data out. We use Google Protocol Bus for that purpose. And so anybody can implement a client to gather that information, dump it into like a Splunk or a Grafana type of data set. So this is just showing you that we're taking a vendor-agnostic approach to operating a hybrid network. The interface and user experience for the network engineer is the same regardless of a Cisco or a SnapRoute or a Cumulus and so forth. So what does it look like if we were to repair this? So let's say that we told the facilities guy, hey, I need you to repair this. We told him exactly what to do. So imagine somebody's pulling out the links, right? The links go red because they're down. And the guy kind of flips them around and he plugs them back in. And then those links are going to go green. And then once they go green, we can see that they are, in fact, cabled correctly. So you get immediate visual actionable information, and then you can see visual immediate actionable results from that. And then we can see that all of the other issues have pretty much been cleared. Okay, how am I doing on time? Am I way over? Yes. Okay, so how I built and designed that blueprint, I'm not going to get to show you how AOS does the port channel mapping and all that. Please come see me if you'd like to see how all that process is done. I'll be out working the booth, so thank you.